Welcome back to yet another episode of OpenSCAD. With all them fancy shapes and stuffity stuffs. Today's episode, it's actually a continuation of the last episode all about for loops, echoes, if, and floor. It's a little too ambitious and didn't get done. Sorry. Let's go get it done now. Let's finish this. So, sneak preview. Why? What? No. I need those slashes. I just don't want any more than those slashes. There. All better. No, don't do it again. Why are those slashes always all weird? Why can't they just be the 3 rows that we've... Well, anyway... We have the chair here from last time. I prettied it up a little because it needed prettying. So anyway, remember how I said last time that if and floor, which are kind of hard to go over without a project. So that's why we're starting out with the chair open this time, and we're gonna get into if and floor part of it since we did the for and echo last time. So to do that, let's make a module. Do module scallop, and we're gonna need to see this module scallop. So we can go up here in our render section and do exclamation point scallop. And now we get nothing but module scallop, which currently is a whole lot of nothing. So do scallop. So the point of this, let's bring back the chair real quick. So the point of this module is to difference it from these modules so we get a stylistic effect. Like just adding prettiness to this. That's the whole point. But we don't want, I'm thinking we'll start with a scallop, which we can do by just differencing a bunch of spheres from these arms and stuff, but we don't want any more spheres than it takes to get a scallop on this arm. So we can do that by putting in a floor. So let's call this, make a variable ymax equals floor. And now floor, you type floor and put all of your stuff that you're going to be doing in parentheses. And what it does is, we copy and paste the length of this here real quick. What it does is it takes whatever operations are in these parentheses and it rounds down. That's all it does. It's nothing amazing. It just rounds down. But it's really nice because you don't end up getting like a half of a sphere or something weird like that. But anyway, it's pretty simple. That's all it is. Let's make our scallop now. Let's see. Let's do a for loop y equals, not t. I don't want t. I want y. Oh, actually, I do want t. It sounds pretty good right now. Maybe I'll brew some up after we get done filming. So y equals 0. Let's do iteration of 5 up to y max, which is going to be, like we said, the maximum number of spheres we can put on this. And then we can rotate this all by something on the y-axis. So 0, let's do y times 90. Let's see what that looks like. And then translate. Now by putting, this is something you don't usually want to do, because when you put a translate under a rotate, it also rotates your translate. So that'll make it to where, let's do, so we currently have it going up on the on the z-axis going by 5, and also on the y-axis going by y, but since we're rotating around the y-axis, the y value is not going to change direction any. But the z value will. Oh, I forgot a bracket up here. but the Z value will, because it'll rotate, which you usually don't want, but it's really nice because when you do that, you get a spiral. Because see, the first time the Z goes up, and it rotates 9 degrees and goes out, and then 9 degrees and goes down, and you get this, which is pretty cool. Isn't that cool? And tips and tricks. And almost, hey, that looks like DNA almost. Like one helix of it. Yeah. Schwanky. So anyway, now we have our module scallop that we can difference from this chair arm. Well, we have half of it. Do you feel like doing the other half? Yeah, let's just do the other half. We can copy and paste most of it. Oh, I didn't mean to cut it. Yay! And now we're also going to need a Z-Max. That sounds like a car. I mean, there is a car. It's called something. I'm not going to say the name for fear of copyright or something like that, but I think you know what it is. Anyway, copy this, and now we have Z-Max. And that's going to be the length of that vertical, mostly vertical thing we have on that. And we're also going to need to rotate it by 5. Copy and paste. Copy and paste, that's all we ever do here. We need to do nothing but copy and paste. We don't need no stinking copy and paste. Also going to make that Z by Z-Max and rotate it, switch out the 5 with the Z, and now rotate, that's what we're doing. Rotate this by the 5 degrees so that it matches the... Yes, Maggie, yes, someone is at the door. Must you bark at them? Please ignore that. What's wrong? Okay. Whoa. Hey. That looks funny. I don't know why, but that looks funny. Okay, so what happened here? What? That's we're gonna need to translate that. So, but let's fix this. Unknown variable y. Oh, I forgot to change that to z. That needs to be z. Oh, whoa. Ooh, that looks cool. That looks very intriguing. Still not what we want though. So I think our rotate, yeah, rotating around the y-axis. We're gonna need to want to rotate around the z-axis. So copy and paste. Gotta copy and paste. There we go. That looks much better. Then we're gonna have to translate this over because it's in the wrong spot. And then translate this by, gonna need to translate it down by the I think just translate. Know what? We have convenient variables right here, like y max and z max. So the z is 0, the y is going to be y max, and the z is going to be z max. And that should make it all nice and pretty. Oh, whoa. Negative z max. Hey, there we go. Perfect. So now we have the entire module scallop, which should scallop the entire thing. Wait a minute. To get rid of the entire thing, because there's no space in there. How do we fix it? Oh, hey. Why don't we translate, let's see. Our arms are log radius around. So why don't we just translate them by 5 plus log radius divided by 2? Hey, that'll work. That works perfectly. Plus log radius divided by 2. Okay, now we have our completed scallop module. So now if we come up here to our module arm, we can do a difference. Now actually, we want to cut that out, and we want to put the difference down here, I think. We'll see if I'm wrong in a second. Difference, and we can put in this, and then We're gonna need to union that. No, wait a minute. Wait a minute, because we translate this and then we translate. Oh well, we'll just do it twice. So yeah. No, wait, we want the difference there. I don't know. So let's separate that a little. Okay, yeah. So we difference that, and then we difference our scallop. And then we do it again on this module. Needs then the translate, so translate the scallop as well, so that it translates the scallop. No, I want to enter, not slash. Difference, and then our parentheses and bracket. Control I to make that pretty again, and scallop. Gotta close off the difference and get rid of this little debug we got up here. Whoa. What happened? No. No. Oh, no. That's not right. What's going on here? Compilation failed again. Oh! I forgot to close off that difference. Hey, it works now. Okay, so there's our scallop module on that. Now let's do it on this one. Fix it up so we have it both. Difference. Two F's, not two I's. Difference. And that needs to be under the translate. So cut and paste. Cut and paste. Cut and paste. What will we do without cut and paste? Scallop. Ah! Forgot to close off the difference again. Whoa. That's not right. That's not right at all. Hashtag. Not the... What? Hashtag that. Oh. I see what's going on here. I get it. I get it now. Put our difference in the wrong spot. So now let's cut that out. Gotta fix it. Control V. And we're gonna need to make this part a union, so that we don't end up differencing this log from this log. So we gotta union those two logs together, and then we gotta pretty it up. Control I, and now close off the difference. Is it already? Whoa! What happened? What happened? What happened there? What's going on? What's going on? This looks fairly strange. Okay, so apparently our translate got all funkyized here when we unioned that. Let's try getting rid of that union again. Whoa. Okay, so now we're differencing the cylinder from that cylinder. This is very strange. Let's figure it out together. So our Z translate is off. -5 times. Oh, hey. Right? Is that gonna be it? F5? No, that's not it. You think maybe if we just translate it down by the... Let's just translate down by the height of these. Chair height minus log number times log number minus 25. And cut and paste. Gotta cut and paste. And negative. Where's that comma? There it is. Negative. Whoa. This is fairly strange. Okay, so it's not gonna be chair height. It's gotta be chair height. Height. Chair height minus chair height? No. Chair height minus log number times log number. Parentheses around that. Plus 5. Let's see, how much time have I taken being an idiot? About 15 minutes. Let's just cheat and make it pretty. Plus 55 plus 60 plus 56 plus 56 plus 60. Hey, plus 60. That looks pretty-ish. Let's get rid of this hashtag on the scallop module. Plus 65 plus 64. There we go. Yeah, you're not supposed to do it like that, but oh well. Got a time constraint here. So now we union this. Sorry for that delay. We have technical difficulties. So union that. Oh, hey. Loading. Rendering polygon. Oh, I must have hit F6. There we go. Oh, that looks... It's not quite what we were expecting. I think we gotta translate our scallop over this one over a little more. Let's see. Yeah, we gotta, let's move it back. So, translating it by Ymax minus 10 minus 5 minus 4 3 4. And the back of that looks in front of that. Just me, or does that seem a little big? Oh well, let's get rid of that hashtag. Hey, that looks a lot better. So now we have our floor and stuff, but let's say we don't want this pattern on here, because that ended up being rather ugly. I don't know. I don't like it. But someone else does, so let's not get rid of it. So to do that, we're going to need to add a parameter up here in our module arm. What did I do? What happened? What happened? Okay. Up here in our module arm up here. So add a parameter style. And then we can say if style equals, make sure it's 2 equals, to make sure it's checking that it means equals, and then you can put a quote to say, to make a string variable, which is a variable of words. And don't worry about that. So if style equals scallop, then, in parentheses, open our brace, and then close it off. And now, it's not there anymore, but we can go up to this arm and say this arm style equals scallop. And now, style equals scallop. Style equals, what? S-T-Y-L-E-S. What's S-T-L-Y-E? Oh, hey, I spelled it wrong down here. Style. There we go. So now, you can see one of them, style equals scallop, which happens to be this one, and we have our scalloping on it. And this one, style equals nothing, because we didn't say anything. So, it doesn't difference our style module. And you can do that with hundreds of modules. We can make as many styling modules down here as we want. Do like scallop checkering zebra stripes. And just keep putting in if statement that says style equals zebra stripes, and it makes the zebra stripes. I don't know why you'd want zebra stripes, but you can make zebra stripes and make it optional. Which that's really nice, like for 3D printing, because you could just say if someone wants zebra stripes on their chair, just make a zebra stripe module and say the style equals zebra stripes for this one, and then it prints out a chair with zebra stripes. Yeah, I should really stop saying zebra stripes. That's actually kind of a tongue twister. You say it really fast. Zebra stripes. Zebra stripes. Like sounds like zebra strips. These strips of zebra. Well, that's about it. So, is there anything else we're supposed to go over today? Was we supposed to go over if and floor? Yeah, that's it. That's it. Oh wait, there's one more thing I forgot to go over. But I don't know how to put it into this module. So we're just gonna save that, then open up a new one. Open start screen so that we have all this fancy stuff, because OpenSCAD doesn't usually open up. So the one I forgot, I should have probably put this in last episode, but it's a different kind of for loop. It's an intersection for. Now it works the same as a for loop, only instead of rendering it all, it only renders where everything intersects. So you can say something like, see, R equals bracket 3, just put in random numbers, 7 and 24. There we go. But I think that might actually be round. And anyway, we can do that and rotate this by R times 2. Just putting in random stuff right now. I did not plan this out at all. Cube R times 2 R divided by 2, and then close that off. Gotta open it first. And what? Oh, semicolon. There we go. Intersection. There. And you see, out of all that, we get this little weird nubby thingy. If we get rid of this intersection, let's cut it out so we can put it back. You can see that we have all of these cubes. But if we put that intersection back in, we only get this little nub. That's because that's the only place where all of these cubes intersect. So let's say this time, let's make that a little more obvious to see this, so more ground gets cut. Whoa, what's going on here? Oh, hey, that's why. Center equals true. There, now they're all in the center. Then we put that intersection back in. Control V. Not Shift V, Control V. And now we get this. Which, well, you could probably make that without the intersection. But, like I said, the intersection 4 is sort of like the intersection that we went over before. Because I really have never found a use for intersection 4, because I mean, that's just a cube. But the more you know. Didn't I say that last time for the normal intersection? Huh. I'm really original. Well, anyway, so we went over the mostly useless intersection 4. If you guys come up with something that actually uses that in a practical sense, please send me like the video, because I'm really interested in what this is good for, but I just can't find it. And then we also went over floor and echo. We went over floor and if. Those two very, very useful modules. And that's about it. So I guess I'll see you guys later. Bye.